Crude oil is the lifeblood of modern society. We extract it from the earth. In its raw form, it's not very useful. It's a thick, black liquid. This liquid is a complex mixture. It consists of hydrocarbons. These are molecules made of hydrogen and carbon atoms. Refining crude oil is essential. This process transforms this raw material. It becomes a wide range of useful products. These products fuel our cars and aeroplanes. They heat our homes and power industries. They even form the building blocks of countless everyday items. Think plastics, fertilizers, and cosmetics. The process of refining crude oil is like a giant, intricate puzzle. It involves separating the different hydrocarbons. It requires transforming them into usable forms. The journey from crude oil to the products we rely on is fascinating. It's a testament to human ingenuity. It reveals the hidden potential within this black gold. Before the real magic of refining begins, crude oil must undergo a crucial pre-treatment desalting. This step is vital. It removes salt, minerals, and other impurities. These impurities can cause problems in later refining stages. They can corrode equipment. They can also disrupt the chemical processes. Desalting typically involves mixing the crude oil with water. The water is often treated with chemicals. This enhances the separation process. The mixture is then channeled into a desalter vessel. Here, an electric field is applied. This helps to coalesce water droplets. These droplets attract the impurities. The denser water and impurity mixture settles at the bottom of the vessel. Meanwhile, the cleaner crude oil floats to the top. The purified crude oil is then drawn off. It's ready for the main refining processes. One of the most critical stages in oil refining is atmospheric distillation. This process separates crude oil into different fractions. Imagine a giant tower called a distillation column. It forms the heart of this process. Inside, crude oil is heated to around 350 degrees Celsius. This causes hydrocarbons to vaporize and rise. Trays inside the column cool the vapors. As they cool, they condense into liquids. These liquids are collected as different fractions. After atmospheric distillation, a heavy residue remains. This residue still contains valuable hydrocarbons. However, these hydrocarbons have very high boiling points. Extracting them requires a different approach: vacuum distillation. Vacuum distillation operates on a simple principle. Lowering the pressure lowers the boiling point of liquids. This principle is applied inside a vacuum distillation column. The pressure is reduced. This allows the heavier hydrocarbons to vaporize at lower temperatures. This prevents them from decomposing at the higher temperatures required for atmospheric distillation. Inside the vacuum distillation column, the residue from atmospheric distillation is heated under reduced pressure. The heavier hydrocarbons vaporize and rise through the column. They condense on trays at different heights. This depends on their boiling points under vacuum conditions. Vacuum distillation yields several valuable fractions. These include vacuum gas oil, lubricating oils, and waxes. The remaining residue, often called vacuum residue, can be used for asphalt production or further processed. Conversion processes, breaking it down and building it up. Not all crude oil fractions are created equal. The demand for lighter products like petrol and diesel often exceeds the naturally occurring proportions. This is where conversion processes come into play. These processes chemically alter the size and structure of hydrocarbon molecules. They create more desirable products. One such process is catalytic cracking. This process breaks down large, heavy hydrocarbon molecules into smaller, lighter ones. This is achieved by using a catalyst. A catalyst is a substance that speeds up a chemical reaction without being consumed itself. Catalytic cracking is crucial for producing petrol. Another important conversion process is hydrocracking. This process adds hydrogen to heavy hydrocarbons. This breaks them down into lighter, more valuable products. Hydrocracking is particularly useful for producing jet fuel and diesel. Coking is another conversion process. It heats heavy residues in the absence of air. This concentrates carbon, producing coke. Coke is a valuable fuel source. It is also used in steel production. Treating and finishing refining the refined. Even after distillation and conversion processes, the refined products require further treatment. This ensures they meet stringent quality standards and environmental regulations. Hydrotreating is a common treating process. It removes impurities like sulfur, nitrogen, and metals from the refined products. It uses hydrogen and a catalyst. This process is crucial for minimizing harmful emissions. It also protects catalysts in downstream processes. Desulfurization is another vital treating process. It specifically targets the removal of sulfur compounds from fuels. Sulfur dioxide, a byproduct of burning sulfur-containing fuels, contributes to acid rain. Desulfurization is, therefore, essential for environmental protection. Other treating and finishing processes include sweetening and dewaxing. Sweetening removes foul-smelling sulfur compounds, improving the odor of fuels. Dewaxing removes wax from lubricating oils, preventing them from solidifying at low temperatures. These treating and finishing processes are crucial. They ensure that the final products meet the highest quality standards. They are safe for use and environmentally acceptable. Blending, creating the right mix for every need. The final stage in the refining process is blending. This is where refined components are carefully mixed, creating final products with specific properties. These properties meet specific requirements. Blending is a precise science. It requires understanding each component and the desired final product specifications. For example, the octane rating of petrol. Blending involves adding specific additives. These enhance performance and reduce emissions. Common additives include anti-knock agents and detergents. Anti-knock agents prevent engine knocking. Detergents keep fuel systems clean, ensuring optimal performance. Blending meets diverse consumer needs, ensuring the highest quality products fit for their intended purpose. From crude to useful, a journey of transformation. The journey of crude oil from the ground to our everyday lives is a fascinating one. It is a testament to human ingenuity. It involves a complex series of processes. These processes separate, transform, and refine this raw material. From the initial desalting to the final blending, each stage plays a crucial role in maximizing the value of crude oil. The refining process provides us with a vast array of products. These products fuel our world and enhance our lives. As we move towards a more sustainable future, the oil refining industry faces the challenge of reducing its environmental impact. Innovations in refining technologies, coupled with a shift towards cleaner energy sources, will shape the future of this essential industry. The journey of transformation